Hello, welcome back to another lesson. We are sort of finishing up our unit, culminating in this absolute values inequality. So we have our three goals, and really we're sort of combining the last couple weeks into one final mega lesson. So our goals are to find two solutions for absolute value inequalities. Because when we have absolute values, that means that there's going to be sort of a positive and a negative version of the answer. We're going to be graphing multiple solutions on a number line, which I think you're probably getting tired of, but it's an important skill. And we're also still writing interval notations. So we just want to remember that absolute value inequalities have two answers. So sort of like one for the positive solution and one for the negative solution. So when we have absolute value, just remember that if we have something like x, absolute value of x plus 5, if we were saying equals 3, then remember that we want our two answers. We want one to equal positive 3 and one to equal negative 3, just because the absolute value of a negative also results in a positive. So what we would really write it out as is two equations. We would have the positive version, x plus 5 equals 3, and the negative version, x plus 5 equals negative 3. And after we solve those, we would have our two answers that would work. So as we get into our examples, it's a little different with inequalities. So we have, for number one, absolute value of x plus 5 is greater than 9. So when we want a positive and a negative version, there are a couple different ways to do it. For the positive version, it's very, very simple. When we are left with just absolute value, the positive version, we're just basically copying down. X plus 5 is greater than 9. If we subtract 5 from both sides, we end up with x is greater than 4. Piece of cake. For our negative version, you have two options. What you can either think of it as is you can write it out as x plus 5, so we're keeping that the same, but then we're going to switch our next two things. We would switch the inequality symbol, and we would switch our final answer to be negative. That is one option. That's probably the easiest option because it's very consistent. Flip the inequality symbol and change your final answer to negative. The other way you could think of it is you could have your x plus 5, and you could make that negative. So you could have negative version of x plus 5 is greater than 9. What we do here on the right, if we subtract 5 from both sides, we would get x is less than negative 14. Where here, if we distribute the negative sign, we would have negative x minus 5 is greater than 9. That would turn into negative x is greater than 14. And after we divide both sides by a negative, we'd be left with x is less than negative 14. So either option is fine. This top option is probably a little easier. Flip the inequality symbol and make the answer negative, or switch the answer from negative to positive if it is negative. All right, and then after that, we would realize that this is an or situation where x is greater than 4 or less than negative 14, and we'd be able to graph that. For question like number 2, we have absolute value, and then we have this minus 1. So we want to get rid of everything surrounding the absolute value first. So you'd have to add 1 to both sides before solving. Then you would have absolute value of 2x plus 3 is less than or equal to, 14 again. And positive version to solve, 2x plus 3 is less than or equal to 14. The negative version, we have 2x plus 3, switch the inequality symbol, and make our answer negative. And we will be able to solve both of those and graph them. I guess we can finish that off. That would be 2x less than or equal to 11. X is less than or equal to 5.5. Here, 2x greater than or equal to negative 17. X is greater than or equal to negative 8.5. So this one is an and, right? Because we are greater than negative 8.5 if we had a number line. So if this was like, oh boy, I'm not going to make this number line great. That's okay. If we had like negative 10, negative 5, 0, 5, 10, right? We would have x is less than or equal to 5.5, greater than or equal to negative 8.5, and that would be shaded towards the middle. So that is an and, which means the interval notation is bracketed from negative 8.5 all the way to positive 5.5, whereas the other one was an or. So here the interval notation would be negative infinity to negative 14, or 4 to infinity. All right, last example. We're not going to go through this whole thing just for the sake of time. We have a 4 times the absolute value of 3x minus 5 plus 2. We still want to get rid of everything besides the absolute value. So we're going to be subtracting 2 from both sides first. So we have 4 times the absolute value of 3x minus 5 is less than 20. Then we'll divide both sides by 4 to get absolute value of 3x minus 5 is less than 5. And from there, we can make our two equations. 3x minus 5 is less than 5. That's our positive version. And then 3x minus 5, we're flipping the inequality, making our answer negative. And now we can solve both of those, which I'm sure you can do. If you want me to do it, we can say 3x is less than 10. X is less than 10 thirds. And then we have 3x is greater than 0. Divide both by 3. X is greater than 0. So x is less than 10 thirds, but it's greater than 0. So that's another and. Hope this made sense. Let me know if you need any help.